Hello. Today we're going to cover Pangaea and the theory of continental drift. I'd like to remind you that you can pause this at any point if you need a little more time to write something down or make a drawing. You can also rewind if you need more clarification or you want to look at something again. So let's begin. Let me tell you a story about a man. He went to his girlfriend's house, and the girlfriend's father was a famous scientist, and he wanted to impress the father to make a good impression. They happened to have a map out because the father was a geologist, and the man said, "Doesn't the east coast of South America fit exactly against the west coast of Africa, as if they'd once been joined?" And this is what he's talking about right here. Now, I don't know if he impressed the father or not. He did end up marrying the girl. But that man, his name is Alfred Wegener. Here it's spelled with a W, but it is pronounced with a V. And he, as a young scientist, was curious about the continents, along with wanting to impress the dad. And in 1910, he came up with this idea that said all the continents were once joined together in one big landmass, one supercontinent, and that they've moved or drifted to where they are today. And he named this landmass Pangaea. And Pangaea in Greek means all land. Now, here's the basic idea. He theorized that between 200 and 300 million years ago, all the continents were once just one big continent. Again, there it is, Pangaea. And he initially just started with the shape. You can see South America and Africa fitting together, and here's North America and Europe and India and Antarctica, Australia. He just went with the shape and kind of did it like a puzzle piece. And that those broke up and then drifted into the 7 continents we have today. And that's why he called it the theory of continental drift. Now, as we've learned before, a theory is not just a guess. It's a scientific idea that needs to be backed up with evidence. So Alfred Wegener went looking for evidence, and he found 4 different things that he felt proved his theory of continental drift. So let's go through his evidence and see what you think. First, again, he started with fit of the continents. This was the very first clue he had, and he's not the first scientist who have thought about that before, but he is the first one that put it out as a big writing that he wanted people to see. And again, if you look at some of them, they fit together like a jigsaw puzzle. Here's again South America and Africa. But just like with a puzzle, if you had puzzle A and someone brought it to you and said, "Did I get all the pieces right?" and there was nothing on them, it would be a little hard for you to say for sure that everyone was perfect. Versus B, when we have more information like a picture, we can definitely say, yes, those puzzles fit, and I understand why they fit. So he knew that the fit of the continents wasn't good enough. He went looking for more evidence, and here's what he found. He found fossil evidence. He found that there were fossils from the same plants and animals on many, many different continents. Now remember, right now, our continents are thousands of miles apart and separated by vast, huge oceans. If there hadn't been Pangaea, then what's the explanation for how these got across the oceans? Let's look at what he saw. We're going to focus in on a few of them. Here's the Mesosaurus. This was a freshwater reptile, so it only swam in freshwater. It could not have swam through the ocean. But they found the fossil remains on both South America and Africa, and when you line them up, they match perfectly. Here's a fern, a prehistoric fern called a Glossopteryx, and it is found not on 2, but on South America, Africa, Madagascar, India, Antarctica, Australia, 1, 2, 3, 4, 5, 6 different continents. Again, if these weren't all together at one point in time, what's the explanation? There were no people there. There were no boats, there were no airplanes, there was no way for these plants and animals to have arrived at exactly the right spot on all of these different continents if they were all separated by water. So he used that as kind of the picture on the puzzle to say, look, I believe that these were all together, and this is my evidence. But he kept looking for more, and he found more. The next thing he saw was rocks. And what he found is that there are lots of mountain ranges throughout the world that once he put his Pangaea puzzle back together, he found they lined up perfectly. And it wasn't just they physically lined up. He also found that they had the same types of rocks and the same structures of the same ages. Now, if they just lined up, it might have been coincident. But now we're talking about rocks with the exact same mineral composition of the exact same age. One of the best examples is the Appalachian Mountains in North America and the Caledonian Mountains in the British Isles. And again, when he puts it back to Pangaea, you can see it makes one uninterrupted mountain range. Now, there are a couple islands here, and the ground has been underneath the water, but it matches up perfectly. But Wegener wasn't done. He had his fit of the continents, he had his fossil evidence, he had his evidence from rocks, but he wanted more. He went to what's called paleoclimatic evidence. Now, the climate is talking about weather over a long period of time, and paleo means really, 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 really old. So we're talking about really, really, really old weather. How can we see that? The best way to see that is weather that stays around for a long time, and that's glaciers. They can sometimes stay for thousands and thousands and thousands of years. And just like if you run water down the beach into the ocean, it leaves a trail. Glaciers, as they move over land, also leave a trail. That's what they're called, glacier scratch marks. And there's evidence that there were glaciers covering parts of several continents at the same time. And not only several parts at the same time, but many of those same continents are now near the equator. As we know, the equator is the hottest part of the Earth. And why would there be glaciers made of ice by the equator? So here's some scratch marks. This one is actually from a portion of South Africa of a glacier being on there. Now, here we have South Africa right near the equator where no ice is going to form. And they found that they're the same glacier scratch marks on all of these continents. And again, when Wegener put his puzzle piece of Pangaea back together, they all matched up perfectly. They were all rotated down by the South Pole, down by Antarctica. So we have these evidence mounting. We have 4 different pieces: the fit, the fossils, the rocks, and now the paleoclimatic. And yet, his hypothesis was rejected. Although he had the evidence, the issue for Wegener was he couldn't explain how it happened, or when, or why. He was theorizing that yes, all the continents were moving and they went from being Pangaea to now being where they are, but he couldn't explain the how. Years later, after his death, the theory was accepted after we got new information, and we will talk about that new information in our 5th lesson, where we talk about finally the theory of plate tectonics and what new evidence was brought to light that allowed us to understand exactly how this is happening. Here's Wegener on his last expedition. He was in Greenland, still looking for more evidence when he died in 1930. I hope you've enjoyed learning about the theory of continental drift and Pangaea, and I'll see you in class.